Okay. 8.1. Finding roots. Okay. So first I'm going to give you just a little vocabulary. I'm not going to necessarily use this vocabulary directly other than instructions. But if you have something written as this sign here, this symbol is called a radical sign. This A is the radicand. I will never use that word. Actually, I had a student asked me what a radicand was not that long ago. I was like, I don't know, it's one of the parts, right? It's one of those things you don't need to actually keep track of. You just need to have a ballpark, you know, what it has to do with. Alright, so the square root of A, this is a whole radical expression, means no equal sign, just one big clump, one big term. Okay, and then a couple other vocabulary words right below it. If you have a root that looks like, and I'll separate this a little bit, this is still vocabulary, I just don't want you to get mixed up that it has to do with that. If you have the square root of A, it can be written either with no number there or with a 2 there. Either way, we call this the square root of A. That's how we would say it. Or the second root, right? Often people get cube root and square root mixed up, so you could always just say the second root, and that would totally be correct. Okay, you could also see any number here. So if it's a 3 there, you could say the cube root of A, or the third root of A. And those are the two just terminology ones that you'll hear people misuse. After that, this is just the fourth root, and after that, dot, 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 fifth, sixth, and so on. Okay, you can take any root of a number. Alright, so the big idea behind this section is the square, well, that pen doesn't work at all. Alright. The square root of A means, or let's even use a number, let's say the square root of 9, means what number to the second power equals 9. Right? Similarly, the cube root of 27 means, and you could just rewrite it as question mark to the third power equals 27, right? That's how you would translate. That's what the question is really asking. And that's what all the first problems will be, is just evaluate or simplify, and you'll be doing a lot of square root of 9 is 3, square root of, whoops, that was supposed to be 27. Okay, cube root of 27 is also 3. Right. Now, one big idea that you hit right away. Oh, do I want to go to that yet? Let's not do that yet. Let's do this in a little different order. Okay, so let's just evaluate a couple of these. Alright, so here's the first couple. The instructions will say evaluate, or they will say simplify. Since this is just an expression, you're just trying to get its value, you're not actually solving. Okay? Square root of 16, 4 is negative square root of 16, and 6 is square root of negative 16. Alright, so what would be the square root of 16? Yeah? 4. Exactly. So this equals 4. Whoops. Because 4 squared is 16, right? That's the number that if you square it is 16. And we'll get to the whole negative thing in a minute. Okay, what about negative square root of 16? 4. Yeah, it would be negative 4 because this is 4. So if the negative is still there, and then the circle that comes first is 4. So this is negative 4.
That's
Right.
not the opposite of the square root of 16?
Well, that is how you could read it. I mean, the opposite of just means negative 1 times. But 6 might be what you're thinking of, and this one's totally different, right? So this is saying square root of negative 16. So this is saying what number squared equals negative 16, whereas this one, order of operations, says we do the square root first, because it's actually an exponent. It's that whole negative 3 squared is negative 3 in parentheses, is it not? Right? Because the square root is actually an exponent. Not is similar to, it literally is an exponent. X to the 1/2 power is the exact same as the square root of x. Those are exactly the same thing. We just have a nice easy symbol to use to treat it for a while, and then later on we get into using fractional exponents, and you'll use this more in calculus when you're dealing with x to the 3/2, x to the 5/2, x to the 3/4, and solving equations with fractions as exponents. But that's later on. Right now, we're just going to deal with the square root sign, but just know the square root is an exponent. 100% is. Okay. All right, so that's why order of operations says this comes first, and then we have the negative outside. You could also think of it like parentheses, because a horizontal bar always says the things below and above are grouped. So you could also think of the 16 being in parentheses. You have to do that first. All right, so square root of negative 16. What's that one? It's kind of like a little trick. Say right now.
Plus or minus 4?
Break it down.
Well, let's think about it. Okay, so 4 squared is positive 16. Negative 4 squared is also positive 16. So we would just say, it's not possible. Or the way you would answer this correctly, and I'm not going to be particular about how you write this, you would say, not a real number. Okay. The reason is, and you don't need to write this kind of offshoot, the way we would split this up is we would say the square root of negative 16 equals the square root of negative 1, which totally does not exist. You can't square something and get negative 1 times square root of 16. And you would say, okay, so this is 4 times whatever this square root of negative 1 is, and the square root of negative 1 is the imaginary number. In math, we just said, hey, let's pretend that that exists. Okay, let's just leave it there. And so we would say that this is equal to, and we just call this I. I is the square root of negative 1. We just name it that. Nothing special about it, we just name it. And so this is, our answer would be 4I. Okay, again, later on, that's also in 263, but we treat it just like a square root, because that's essentially what it is. We're just saying 4 times square root of negative 1, except instead of writing square root of negative 1 over and over and over and over, we use I. Okay? But yeah, so right now, we won't get into the whole imaginary square root of negatives. If you ever see a square root under a negative sign, you just say that's not possible, or you just say it's not a real number, it does not exist, anything like that.
Only the square, right? So it's to the third, it could be.
Bam, and that's gonna be a question that comes up in probably about 10 minutes, yeah, exactly. All right, so since these are exponents, they follow similar rules, so I'm gonna just go through 2, yes, you can do this, and 2, no, you can't do this. So just a few important notes. Oh, these pens falling apart. I'll get brand new pens tomorrow. Oh, it'll be a sweet feeling for all of us. Alright, so a few, okay, pena.
Maybe that's why it was over here.
Alright, is that a phrase in Mexican Spanish too, que pena?
Yeah.
Yeah, okay, just making sure. Sometimes my Ecuadorian Spanish doesn't translate to Mexican Spanish. People are like, what are you talking about? I'm like, in Sudamerica. Okay, a few important notes. Okay, so other than a few negative exceptions, it follows the same rules. So here are the rules. I'm gonna write the normal exponent one that you've done, and then I'm gonna write the root or radical version. Right, so we know that if you have a times b squared, that's the same thing as a squared b squared. Well, same thing's true of a square root, and we're gonna use this a lot in 8.2 and 8.3 to simplify. So square root of a times b is square root of a times square root of b. And since multiplication and division are the same operation, same thing goes if you have a over b. We know a over b squared is a squared over b squared, again, because it's one term. All of these rules work because they're one term. And so same thing applies over here. Square root of a over b is square root of a over square root of b. And then just a reminder, when it's not one term, you absolutely cannot do that. So C would be a plus b squared is 100% not at all a squared plus b squared. Same thing when you have a minus b squared. That's not at all a squared minus b squared. So just a reminder, you definitely can't do that. And so over here, square root of a plus b is definitely not square root of a plus square root of b. And square root of a minus b is definitely not square root of a minus square root of b. Okay, now I'm gonna go over this next part. And this is, it's kind of a small thing to talk about and kind of a big thing, but it's a really hard idea for me to get across. Okay. The second important note. Right, a big question that, confused me for a while is why is it sometimes positive and sometimes plus or minus? So sometimes you have one answer and sometimes you have two, and that always kind of confused me. To make any even root a function, right? We can't have the square root of 49 come out with a positive 7 or a negative 7 different times. Like, that's the idea of a whole function is whatever I plug in, doesn't matter what I plug in, doesn't matter what I get out. But if I plug in that same thing again, I have to get the same answer. Even if I plug that thing in a million times, I could never, ever, ever get two different answers out. We can't have ambiguity in math. I can't plug in one number and get two, plug in the same number and then all of a sudden get five. That machine would be broken, right? So that's the whole idea of a function. When I plug something in, I can't get two possible answers. So what we say is the square root will always only give us the positive answer, okay? So that's the important idea here, is anytime the book writes it is only positive, okay? If the square root sign is already there, it's only positive. All right, the second half of this is if instead there is an equation, and we'll be solving a lot of problems like this. Like, here's an example of an equation, x squared equals 25. Okay, how many possible solutions are there to that equation?
One.
There's at least one. What's that answer?
Five.
5, yeah, there's at least one. But also, what else could you plug in? Yeah, 5 squared, 5 times itself is 25, and negative 5 times itself is also 25. So there's two possible answers. So if you start with an equation, this has two answers. 5 squared is 25, and negative 5 squared is 25. So the idea is, if the book has already written a square root, and there's no plus or minus sign next to it, you're only dealing with the positive. Whereas, so if you take a square root to solve an equation, you need to write a plus or minus. So you don't forget there are two possible answers. Okay, so that's confusing and it'll get easier as we practice it more. But the idea is, if there's a square root written, the square root is only ever positive, always positive, okay? Only outputs positive numbers, ever, okay? However, if there's an equation with two answers and you take a square root, then out front you would say, and just to show you, you have x squared equals 25. So in the next step, I take a square root of both sides, but I can't just kill my negative answers. I need my negative answers still in the problem, so I write a plus, whoops, it's my throwaway text. Okay. I write a plus or minus in there now to say, so my x could be either plus or minus 5. In other words, x equals positive 5 or x equals negative 5, right? Because I took the square root. So I remembered both answers. Okay, and that's what that plus or minus symbol means. It means there's two possibilities. So, small detail, but basically in this whole section, since you're not solving any equations, every answer, you only take the one positive one, okay? Alright, and again, this is for even roots only. For odd roots, negatives just go as is, and we'll see that. Alright, questions on that. That's a hard topic to grasp, I totally get that. Okay, what I'm gonna do is I'm gonna erase this, I'm gonna write up a bunch of examples, I'm gonna have you guys come up and solve them, and we'll talk about it. Okay.
You try.
Yeah, and then the one other thing we're gonna mention after we do some examples is just, I would strongly recommend you memorizing certain values. Not many, maybe like 10, 15 exponents, but just 2 squared through 12 squared will come up so much that having them memorized, you'll just be like, oh yeah, that's 11 squared, or oh yeah, that's a perfect square. And then knowing 2 cubed through 5 cubed. I would know those, so I mean 2 cubed, 3 cubed, 4 cubed, 5 cubed, something like that's a total of, God, the hardest time counting. I think that's 11 and 4, so I think that's 15, yeah, exactly, values. So a total of 15 things I would have you memorize, and that'll really help you. I'll leave that for another minute. Okay. So here's 8 is square root of 1 over 49. 12, negative square root of 1 over 121. Okay, square root of 51 plus 13. Square root of 75 over 3. So show your work when you come up and do these, but I'm gonna have you guys come up and solve these.
Huh? I'll do 24.
Alright, last 3. Yeah, you guys can come up and solve these now. These will be good talking points that we can talk about.
Oh my god, that's been a lot.
Yeah, well, the more practice, the better. I like it, everybody's already on their seat, awesome.
Say -4.
Awesome, nice, look at that, you guys didn't need any help. Very cool. Alright, so let's go through these.
Thank you.
Guys, so I see awesome correct answers and great mistakes too. These are killer mistakes.
Not so much.
It's hard,
Just chunky, just.
it's hard when I'm up here to just like come up with mistakes and be like, this is what you guys will do. So it's awesome seeing some real life mistakes, okay? So the first one, this is perfect. This is how you would do it, is you would split it up to be the square root of one term, that's division, is the square root of the top over the square root of the bottom, so 1 over 7. And again, because the square root was already there, there's no plus or minus, perfect. Okay, over here, everything is right except something disappeared.
Oh, the negative, I
Yeah.
didn't see that.
So, but you did do the square root of 1 over 21 is 1 over 11, because you split it up, square root of 1, square root of 121, everything's right, but that negative just needs to stay there in every step, so the answer would be negative.
Well, then it would be I, because it's -1.
Ah, if it's
Only if it's
inside.
square rooted, if
Yeah.
it was negative in there, it'd be I.
yeah, but outside, we just figured this out first, because it's a parentheses, it's an exponent,
Oh,
and
so it's
after
like,
we get that.
yeah, okay.
Yeah, after we get that, the negative lives outside. Perfect. 18.
You just wrote that in there.
Huh. So 18, perfectly correct. The question was, on that one and 24, how do you write the answer? Well, square root of 64 is equal to 8, because 8 times 8 is 64. The square root of 8 would be some number around 2.8 or 2.9, let's say, and there would be a dot, dot, dot forever. How did I know it was around 2.9, just out of curiosity?
Because 3 would be 9.
Yeah, exactly, because 3 square root of 3 would be, square root of 9 would be 3, and square root of 4 would be 2, so square root of 8 's somewhere between there, and it's closer to the 9, right? So when you take the square root of 64 and you get out, 8 squared is 64, there isn't a square root anymore, because if it was square root of 8, that's a totally different number, that's a teeny little 2 point something. So that's a great question. That square root, you used it. It's just like when you say 8 squared equals 64. You don't say 8 squared is 64 squared, right? You just say 8 squared, you perform the operation raised to the second power, and then the result is 64. So same thing here. The result of taking the square root is 8. So that's a good question. And then we went down one path on 20 and we hit a dead end. What was maybe an alternate path we could have taken? I mean, that's totally correct. You can split it up like that.
Can we
However,
still simplify it still?
Wow.
To be square root of 25?
Yeah, 75 divided by 3 is, you're still within your
25/1.
exactly.
Darn it.
Still inside the fraction. You could have just, or I mean, inside the radical, you could have just simplified the fraction, just like a normal fraction. So this is square root of 25 over 1, or just, I'm
25.
gonna erase this, square root of 25, which is?
5.
There we go, just 5. Right, so we took one path, and yeah, we hit a roadblock. Okay, totally okay. Alright, over here, what about 22? 22 brings up a classic mistake, right?
Was I supposed to minus the 5 and 4?
I don't know, you tell me.
Then 29 and 13.
Subtraction first though?
So-
Subtraction first.
Would you find square root of 25 and square root of 16?
Can I do it?
Oh, sure, come on up and redo it, yeah. Let's see why.
Like it is on 24? Would you like make it look like 24?
I don't know, let's see.
Oh no,
He's
you-
gonna do it
you
right
can't.
now.
You said you can't do that, that's right.
Well, yeah, we'll get to 24, one,
So I
24.
was supposed to, you said order of operation, right?
Yeah, why?
Because inside is 25 minus 16.
Yeah.
That'll be 9.
Mm-hmm.
That'll be 3.
But we do exponents before we do addition and subtraction, right? Yeah, but I mean, what about 22? Don't you do exponents before you do addition and subtraction?
The exponent would be 1.
No, I mean, the square root itself is an exponent. The square root time is an exponent. So come on, defend your order of operations here.
Y'all are just confusing me.
Okay, so when you're writing 3 squared minus 4 squared in the exponent? Or
No,
in
I mean,
the, no, but would you, like,
You subtract it and?
can you write like 5 squared minus 4 squared in the, yeah, like that?
I mean, you could write it like that, but it's just like factoring your number.
And then you,
Well,
Ah,
24, if
yeah.
you already took the square root of 25 and 16, you lose the sign, so just
So
say
5 minus 4 is-
It's true, but let's wait on 24. Let's focus on this. The reason, and I told you guys this literally the first day of class, right? When we talk about order of operations, the reason you do that subtraction here first is what gives away that that's a group.
Is it
because it's
called-
in,
Yeah.
It's inside.
Yeah, it's inside is one way to think about it, or this horizontal bar implies parentheses. If there's ever a line above or below something, this is absolutely in parentheses, and so that needs to happen first. It absolutely comes in a group. Okay, so that's why it comes first. And then after you figure out what this is, that's when you take the square root, which is 3. So over here, the square root ends after 25 and ends after 16. So yeah, you take the square root of 25, which is just 5. Because
Just five.
square root of 5
Oh,
would be
okay.
like 2.1-ish, or around 2.1, and then minus, and this would be 2. Yeah, so it's not square root of 25 is square root of 5. You perform this operation and you get a result of
Okay.
5. And then minus, you perform the square root on 16 and what comes out is a 4.
Which
Yeah.
becomes 1.
Yeah, exactly, which becomes 1. But you're right that here you couldn't subtract those. Those are like unlike terms. That's kind of like an x minus a y.
So pretty much when you square root 25, you don't need to put the square root in.
No, it's not even that you don't need to, it's that you can't.
Okay,
Right, because you use it.
alright.
Again, like 2 squared equals 4. You wouldn't write 2 squared equals 4 squared, because that would be wrong. Yeah. Okay, and then over here, again, just like 22, we did the order of operations and subtracted first, got square root of a negative. Is that right?
yeah.
because you can't take the square, you can't take the square root of a negative because you say some number squared equals -9, but we know any number squared always would come out as a positive, so that's just impossible. There's no way to get it to come out to be a negative. Okay, over here, let's check, is 3 to the third power 27? Well,
3 times 3 is 9 times 3 is 27.
yeah, so it works, that's 27, check. Okay, let's check this one, -4 to the third power would be,
16 times -4.
is -64, check, that's right. This one, we've got the work, but again, we made that mistake like in 24. So, this is almost right, but
It should just be a plain 10,
One
not
over
with a
10.
bar.
exactly, no more cube root. You did the cube root. The cube root of 1,000 is 10, not is the cube root of 10, because then you just keep going deeper and deeper. The cube root of 10 would be some like little, 1 point, 2 point something, and then you go even deeper with that. Okay, so once you take that, you would split that up to be the cube root of 1 over the cube root of 1,000, which you have it split up. But then what you say is the cube root of 1 is just 1 now, because 1 to the third power would be that 1. And then what to the third power is 1,000? Just 10, not that cube root there. So once you evaluate it, that sign goes away. Perfect. Okay. Those are good problems. Okay, I just want to bring up one last little idea. I'm trying to remember what it is. Oh yeah, I just want to write down the numbers I want you to memorize. That's it. And just, some advice. You don't have to memorize these. I'm not going to like quiz you when you walk in the door, and if you don't know them, I'm not going to lower your grade. But you should at least be very comfortable with these. Whoa, where did this pen come from? Alright. So, numbers to memorize. I would for sure memorize 2 squared all the way to 12 squared. For sure. I had somebody yesterday, say, 49's a perfect square. And I was like, oof, man, chapter 8, sorry, tomorrow is going to be rough if you're unsure of that. Okay. Once you get up to higher math levels, maybe memorizing to 16 squared would be helpful, because these numbers just come up so much. And then in terms of cubes, really just 3 cubed, 4 cubed, and 5. Oops, sorry, 2. I forgot 2. Just 2 through 5, really. I wrote this up. I'll rewrite those better. Okay. The reason to memorize these is because the less brain power you use on simple arithmetic and worrying about the numbers and searching for numbers, the more you can focus on the bigger problem, right? The more you get caught up in the little numbers, you lose sight of the big picture and what you're actually trying to do, and that's when big mistakes happen, right? For the next, rest of chapter 8 and some of chapter 9, you're going to need to identify these, because what we'll be doing is saying, okay, simplify. It's just an example of what we do tomorrow. is I would say simplify the square root of 32. Okay, or another example, square root of 50. And what I mean is we're gonna split this into a product of a perfect square times the sloppy extras. And this one will split also into a product of perfect square times extras. So what would be the perfect square over here?
15 and 16.
Yeah, 16 times
Square root.
just 2, right? 16 times 2. You could have also split it to be square root of 4 times square root of 8, but that wouldn't be completely simplified because there'd still be another 4 in there. Okay, so that would be an option, like as a stepping stone. But yeah, this would be then 4 root 2. But identifying what numbers are you looking for? You're seeing if 4 goes in, 9 goes in, 16, 25. So the more comfortable you are with these numbers, the easier these will be, right? So 50, what would we split that into?
5 and 2.
Not 5 and,
25.
well, 25 and 2 to start. Yeah,
5 and 5.
and then it would turn into,
5 times square root 2.
exactly. And so that's what we'll be doing tomorrow, is simplifying. And then what we could do is, if we had something like, and this is going on to 8.3, what we'll be doing tomorrow, is if we had this square root plus this square root, they're totally different. We absolutely can't combine them. However, after we simplified this one, and after we simplified this one, what would 4 root 2 plus 5 root 2 be? And this is again, not on today's homework, but on tomorrow.
9 root 2.
Exactly, because now they're like terms, and that's why we simplify them completely.
So-
Because, yeah,
Yeah, so like, look at the root, when you're looking at it that way, like it's a x or whatever, make sure it's the same, like exponent or whatever, it looks the same, and you put together, combine like.
but you
terms, right?
can't here, yeah, here, if these square roots are the same, it doesn't matter.
This
the
was
square-
on the inside. right?
But yeah, once you get the exact same square root, the exact same square root, it's like 4x plus 5x. Yeah, and so that's why the more you have these memorized, the easier this will be to identify. But don't worry about that stuff till tomorrow. Just saying, get really familiar. There's a couple like 8, 27, and 64 that show up all the time. So just, be comfortable with those.
So that's what we call simplify?
Well, I mean, simplify is any time there's no equal
No,
sign.
simplify.
Oh, yeah, simplify. That's what we, that's
what
when
we're
you have
doing.
square roots.
That's what we're learning.
Simplify.
8.1. Simplify. Simplify, okay.
We get so slang in math, you just drop a letter here, there just to shorten it,
What's that joke?
Protection right there.
Oh, that's what I'm thinking, yeah.
You came up with it? What do you think of that?
You made some cheesy math joke last night.
Good, I wanna hear it.
Your girl gets mad at you, or then you reciprocal. It's reciprocal. She changes